As we continue our exploration of object-oriented design, we're going to introduce a class that represents a noun in this video, and we're going to refactor our program away from something that's using parallel arrays to something that's using classes and an array list, which can build a higher quality program, which means it crashes less often, gives the user a better experience, and it's easier to maintain. Let's start by just quickly remembering what our program currently does. We're representing vehicles in a series of parallel arrays where we have each array representing a different attribute of that vehicle. And then when we want to drive the vehicle, we invoke this method. We pass in miles driven. We iterate over every vehicle, and we drive the vehicle that many miles. We update the gallons of gas, and we update the odometer to reflect the change from driving. So in this video, we're going to see why we should pull the concept of a vehicle into a different class. And that's a very fundamental concept in object-oriented design. The solid principles, the first 5 principles of object-oriented design, I just did a quick Google, came up here to DigitalOcean, so I'm borrowing their website for this, but solid is a well-known concept. So we're going to take a look at single responsibility. A class should have one and only one reason to change, meaning that a class should only have one job. Well, it might feel like our simple class here is doing only one thing, but the reality is we are doing multiple things. We're storing data like so, and we're also doing logic on those data. So what we're going to do is we're going to take the data and put it into a separate class. We're going to call that vehicle, and each vehicle is going to have a gallons of gas, odometer, and miles per gallon. We can create multiple vehicles, and that's what we call instantiating an object from a class. So you can have a vehicle, I can have a vehicle, your friend can have a vehicle, and all of the information about each of our vehicles is nicely encapsulated into that object. That means the object knows all about itself, and we don't have data about the object sitting in other places. So let's go ahead and make a vehicle object. I'm going to go to my source folder, right-click, say new Java class, and we'll call this one vehicle. This is what we'll call a noun class because it represents a person, place, or thing, and it has attributes to represent that person, place, or thing. Let's go ahead, and I'll tell you what, I'm gonna comment out this array, parallel array we had before. I'm going to grab these attributes and just move them over to vehicle and do a bit of refactoring. We'll keep them as private, which means they can only be modified within this class itself. We don't need the word static, though. It's kind of a confusing concept, but to put it briefly, if we have an attribute within an object, it does not need to be static. So I have my attributes here, and now I'm going to right-click, and I'm going to say refactor, and let's say encapsulate fields. Now watch what happens here. Get this lined up just right for us. Watch what happens here is I click on all of these. Notice the file before I hit refactor, and now notice the file after I hit refactor. You see, what it's done is it's given us getter and setter methods, which is really important for encapsulation. So remember, encapsulation means that an object knows about itself and no one else can modify the contents of that object without permission. So what we do is we have the variable set as private, so they can only be modified internally. But then we have a series of what we call getter and setter methods, where a getter method makes the contents of a variable available outside this class, and a setter method allows us to change the value of that variable. It wraps a little bit of protection around the data inside of that class. I tend to think of an analogy here. If you look at a leaf of like a tree under a microscope, it has something called stomata, which is a valve in the leaf that opens up to let water vapor out of the leaf, and in doing so it pulls up new water from the ground. It creates a vacuum and pulls up new water from the root system. But in a time of drought, that stomata can close on the leaf, and it can protect its internal water supply, limiting the release of that water out into the atmosphere. So that's what a getter and setter is like. It's like that valve that can conditionally open and allow access, but if needed can close, and turn off that access. The reality is, in Java programming, we could make changes inside of these getters and setters, but it's fairly rare that we do. Usually it's a straight up getter and setter, but that is a door we can open and close if we need to. So I have now created my class. Now, main no longer compiles because I've taken away those attributes out of main, which is good. They should be in a separate class. Let's go ahead and create 3 vehicle objects that represents the vehicles we were creating in this parallel array in a previous video. So I'll say vehicle, my vehicle, equals vehicle, say new vehicle. And what's going on here? Well, let's take a look at this one line at a time, or one piece at a time. I'm declaring a variable here. What's the variable name? My vehicle. What's the variable type? The variable type is vehicle, where that's the class that I've created over here. Now what do we have on the right side? We have the keyword new, and then vehicle, open and close parentheses. That means that we are creating an object of this type vehicle. So instantiating an object, we're making a new vehicle, and then we can populate it with information. So I can say my vehicle dot set miles per gallon. Now what was our miles per gallon for our first vehicle? It was 20. And then I can say my vehicle dot set gallons of gas, and we know that was 10 for our first vehicle. And then we can say my vehicle dot set odometer, and we'll give that 0. Okay, and at this point we have created our first vehicle. So let's create our second vehicle, because we know we had a second vehicle there with 25, 8, and 10,000. 25, 8, and 10,000. Then we know we had a third vehicle with 15, 12, and 20,000. Oh, we need to give this a unique name, don't we? So we'll say your vehicle, and then we'll create one more, and we'll say our vehicle. So I believe we had, what did we have? I already forgot. 15, 12, and 20,000. Now you might say, wait a minute, I thought you said that we want fewer lines of code, and here we're repeating ourselves. Well, we're creating a bit of dummy data here. We're going to find a more efficient way to do this when we explore JOption pane, so I will refactor this in a future video and make this more efficient. But if you're saying, copy paste, I thought that was bad, that's why I'm doing it. A couple more things we need to do. First of all, let's create an array list of all vehicles. Actually, you know what? I'm going to make that an attribute. Looks like I have a few imports I need to take care of. Now, what's going on here? Well, we know what an array is. An array can hold multiple pieces of data. An array list can hold multiple pieces of data of a type that we specify. And here what I'm saying is we are going to store vehicles in this array list. Oh, wow, this is a complicated line. So first of all, private means that this variable is internal. Secondly, list. You know what? Let's simplify this and call that array list. We'll make it same on left as right. We're declaring a variable here. This is our variable type. It is an array list of vehicles. And the name of the variable is all vehicles. And we're creating an object of type array list, and we're storing it into that variable. That might be a bit confusing right now. If you're not familiar with objects and how we can store objects into variables. So let me just summarize that whole line. Don't get caught up in the minutia. Just know that this thing called all vehicles is a special collection that can hold multiple vehicle objects. Down below we're creating multiple vehicle objects. So after each one I can say all vehicles and then add and then my vehicle, like so. Looks like I might need to make one modification. I think we're going to need to make this static. Private static array list vehicle. Okay, there we go. And then we'll say all vehicles dot add and your vehicle. And under this one, all vehicles dot add. Boy, I called, I just realized a mistake. Our vehicle. I need to make a little change here because you see, I said your vehicle here, but then I'm calling the setters on my vehicle, which is the wrong object. So I'm going to change each of these to your. And similarly down below, I'm going to change each of these to our to make sure that I'm specifying that I want to save this on the right place. Okay, there we go. So now we have 3 different vehicles, and we've added them to the collection all vehicles. Now this loop we're going to simplify a little bit. We're down here in our method that's going to run our vehicles. So what I can do is say for e, and then we'll say vehicle, colon, all vehicles. And that's going to make a nice tidy for each loop, which means it's going to iterate over every vehicle we have in that collection. In other words, iterate means it's going to shake hands with each vehicle in that array list, one at a time. Each time it shakes hands with one of those vehicle objects, it's going to run whatever comes between the open and closed curly. So for that, I'm going to take the logic I had in the previous loop, and we'll just move it in and clean it up a little bit. Now our first line where we're printing out the odometer, I'll say vehicle. And how do we get the odometer value for the vehicle? We simply say get odometer. For gallons of gas, I'll say vehicle, get gallons of gas. Next line, I'm going to say vehicle.set gallons of gas, and then we'll say vehicle.get gallons of gas minus miles driven divided by vehicle.get miles per gallon. Then we'll say vehicle.set odometer, vehicle.get odometer, plus miles driven. Finally, a system out print line, and we'll print the values of this vehicle. And vehicle get gallons of gas. So now, instead of using local variables for each of these computations for odometer, miles of gas, gallons of gas, miles per gallon, so on and so forth, what we're doing is we are creating a series of vehicle objects. Each of these vehicle objects has the data about itself and nothing else. And then what we do is we iterate over that collection of vehicles, which we call all vehicles. Remember, when we create a vehicle up above, we add it to the all vehicles collection. Now down below, we're iterating over this collection of all vehicles, operating on one at a time. So each time we loop, we shake hands with a vehicle in that collection, one and only one. When we loop the next time, we shake hands with the next vehicle in that collection. And you see that this for loop has changed a bit from the earlier for loop that we had. This is a special one called a for each, because we're running this for loop over each of the elements that we have in this all vehicles collection. Let's go ahead and run and see what output we get. So we see that we run our first vehicle, 100 miles, takes it from 10 gallons of gas to 5. Our second vehicle, we run 100 miles. Our third vehicle, we run 100 miles in that order. Then we call this function again. So first time we call the function, we pass 100 miles driven. Second time we call 60. We call it again. We run the first vehicle. It goes from 100 miles on the odometer to 160. We call the second vehicle. It goes from 10,100 to 10,160. And we go to the final vehicle, and 20,100 to 20,160. So we have a much more object-oriented program right now. Net, it's a little bit more code, but as we refactor, we're going to find that it's actually going to get smaller as we make that creation of objects more simple. Also, it is way more flexible than we had before and way less brittle. Number one, why is it more flexible? Well, to add a new vehicle, if we want to add a fourth, we simply duplicate this here instead of dealing with a series of different arrays that have to be coordinated based on index number. Number two, certainly this isn't the only thing that we have with a vehicle. We might also have a color or transmission, things like that. So now when we need to change or modify what we're recording about a vehicle, we simply put it in this vehicles class. And this vehicles class is one entire unit that we see we can pass as one entire unit as we're working with it. And the next thing is our for loop is much more efficient. It is only going to iterate over the number of vehicles that are in this array list. Remember our old for loop, we had a hard-coded 3 because we had three vehicles to iterate over. Now, as we expand the collection of all vehicles, this for loop will simply adapt. If we have 5 vehicles, it will iterate 5 times. 1 vehicle, it will iterate once. 0 vehicles, it will not iterate at all. So we do get the same output here as we had before, but it's much more efficient. It's much more object-oriented because the vehicle class has a single responsibility and the main class has a single responsibility. This is one of the occasions where we can really appreciate what the debugger has to offer. So we have a breakpoint here, and we know that F8 is step over, and we have our drive method down below. Instead of doing run, this time let me do debug. This will run the program and then allow me to run it at my own pace. So F8 will execute a line and run to the next, and we see the system out print line is fairly straightforward. Now, take a careful look right here. Watch this tab right down here as I choose F8 over my vehicle. Look at that. Do you see how we now have something called my vehicle, and it's set to the defaults of 20, 10, and 0, which actually we're just going to reset those same defaults here. So we've created a vehicle object, and we're adding it to the all vehicles collection. And now you see that the all vehicles collection has a 0 element, and it has a vehicle with miles per gallon, gallons of gas, and odometer. Now we're creating your vehicle. So I choose F8 and take a look. We have a new variable down here called your vehicle. So new variable, new object, your vehicle. And I go ahead and I choose F8 through each of these. Now we have our vehicle, which is the third vehicle. And once again, we can take a look in the debugger. My vehicle, your vehicle, our vehicle, and all of these are contained in this collection called all vehicles. Now I'm going to choose drive, but notice I'm on a method call. So instead of choosing F8 to step over, I'm going to choose F7 to step into, which means let me run this and watch it. So take a look at our variables down here, and you'll see, we don't have those other variables which were essentially local to the main method. We only have the new variables that are local to the drive method, and any variables that are declared at the class level static as well. So I'm going to choose F8, and note that we're in a for loop. Now note that we have a new variable called vehicle. And what does that contain? 20, 10, and 0? That contains the very first vehicle of our collection. So now we're going to run the vehicle, and we're going to invoke set gallons of gas. Now, curiously, we have several method calls here. We have get miles per gallon, get gallons of gas, and set gallons of gas. Remember that F7 is different from F8 in the debugger. F8 means run this line, go to the next. F7 means if there's a method call, I want to step in and see that method. So if I choose F7 here, where are we going to go? Look very closely at the tabs at the top here. I choose F7, and we go to set gallons of gas, but notice it's within this vehicles class. So the debugger can help us as one class is calling methods on another class. It can help us to navigate where the logic is actually going, which is why the debugger is such an important tool. And notice right now, if we take a look at this object, 20, 10, 0. Again, we are still dealing with that very first object. So I go to the set odometer, and then I go to the print line. We're back in main again now, by the way, if you didn't notice. Now I iterate again and take a look at what's in the vehicle variable this time. Is it our 10, 20, 0? No, it's our 25, 8, 10,000. It's that second vehicle that we've created. And now all of these lines that we run here are going to run with that second vehicle that we set up as 25, 80, 10,000. Again, look up above. First vehicle, 20, 10, 0. Second vehicle, 25, 8.0. I think I said 80. I meant 8.0. And 10,000. Third vehicle, 15, 12, and 20,000. So when we're running a for each loop like this and we're iterating over a collection, remember each time we iterate or each time we run the logic between these curlies, we're grabbing one of those items from that collection and we're shaking its hand, and we're operating only on that item. So once again, I can choose F8 to step over a line. When I choose F7 to step in, notice I go back to this vehicles class again, but this time the data are different from what we saw before because we're operating on the second vehicle, not the first vehicle. F8 takes me back, and we're going to loop one more time. And this third time, what's in our vehicle variable? Well, this time it's 15, 12, 20,000. Okay, and what does that line up with? Well, that lines up with this third object we created, 15, 12, 20,000, because we've already processed the first, we've already processed the second, and now we're on to the third. No big surprise, if I choose F7, we're going to step into that vehicles.java again, but this time, when we look at the variables for this vehicles.java, we can see them down here in the lower pane. We can also see them up here, and we can mouse over them to see their current value, 15, 12, and 20,000. We're dealing with only that specific vehicle, not the other vehicles. So I'll go ahead and choose F8, which will take us back to our running program, and it will print out the results. So you can see that the debugger really helps us step through all that and visualize how two different classes can work together. Our main class, which is effectively doing actions or verbs, and our vehicle class, which represents a noun and the state of that noun. The state is represented by those variables that we've created thus far. One more thing we could do if we want is we actually could take this logic and the computational logic. It kind of feels like it believes like it needs to be in that vehicle class. Be a little more efficient if we did. So what if I just said vehicle.go miles driven? What if I make a new method on that vehicles class? Well, notice that I'm calling a method that does not yet exist called go, but our IDE can help us out here. Create method go in vehicle, and there we go. Now we're in the vehicle class, and now we can paste our formula that we came up with earlier. And as a matter of fact, we can take off these vehicle qualifiers, because right now we're within the class called vehicle, so we don't need to reference it. We're just using local data. Save. That looks a lot more efficient. And notice that we're calling the functions that are, or the methods rather, that are directly in this class. We could even refer to the variables directly if we wanted to. I'll go back here. We see that this looks much more efficient. Once again, if I save and run, we'll see the exact same output, but it's more concise. It makes the program makes more sense because we have all of the information about a vehicle and all of the logic about a vehicle in this single vehicle class. And the main class is simply here to run the application. As a matter of fact, I can take away that parallel array system we had earlier, and we see the main class nice and clean. So I hope this video has been a helpful look at how to convert from that thought of linear sequential thinking into true object-oriented design. And as always, I look forward to reading your comments. Thank you.